Last image that we took before we turned off our camera on approach. We know there's a huge risk, and we got everything on the spacecraft focused on the activities tonight because it's so difficult and because it's risky. The spacecraft is incredibly capable, but we narrow it down so only the systems that we absolutely need are on. And so all the science is really turned off. And we did that 5 days out so that we could have the whole spacecraft and the team focused on the engineering. But right before we turned everybody off, we took this last image. Can I have that? So there's Jupiter. We're still several million miles away when we took this image. It was a couple days ago. What you can see very clearly in this image, the 4 Galilean moons, I pointed those out earlier. Of course, they're orbiting, so they're not in order like they were in the nice figure that I showed earlier, but Callisto we passed, Ganymede last night, Europa we're passing in about an hour right now, and Io is the innermost one. One of the best things that I love about this image is not only can you start to see the zones and belts, but if you look closely you can actually see the red spot facing at us. And this is it. This is the beast we're going after. And we're going to conquer that thing tonight, and we're going to get the answers we're all seeking about the beginning of our solar system. So I hope you all come along for the ride. Thank you.
Well, thank you, Scott. And we're going to open it to the floor for questions. Please state your name and media affiliation. Get the gentleman in front of there.
Hi, I'm Bruce Lieberman with Air and Space Magazine. Can you clarify for me how long it takes for Juno on this capture orbit tonight to go from the North Pole to the South Pole? How long is it in this dangerous zone? And then does that time period change during the science orbits?
Tonight that'll be about 2 hours, 7:30 at the North Pole to about 9:30 at the South Pole. And the burn is 8:18 to 8:53 p.m. And this is a 53-day orbit, so I think that period will slow down a little bit when we get into the longer orbits.
So during the 2-week
14-day orbit, sorry, later on.
So during the 2-week orbits, the close approach is also 2 hours or a little shorter?
It's approximately the same.
Okay, thank you. Back there.
Hi, Joe Palca from NPR. A question about the tracking and the Doppler and the tones. Is it the same radio frequency that's sending the tones, that's sending the signal for measuring the Doppler shift, or are those two different radio systems?
The tones are subcarriers positioned near the carrier. So the carrier is the high frequency signal that we use to look at Doppler shift. And then the tones are where we typically would modulate or mix the data and the telemetry with the radio signal, but in this case it's just a simple subcarrier tone. So it's slightly shifted off of the main carrier.
So it's just sending a signal this way, it's not a return
It's a one-way,
timer.
it's a one-way transmission. It's a single frequency, just like you hear when you have an emergency broadcast system test in your car and you just get that tone. And we have different frequency tones that are sent to mark different milestones.
Thanks.
Thank you. A reminder for reporters listening in who would like to ask a question, please hit *1. And we've got a question with the gentleman blue in the back of the row.
Pete Demetrio, KNX 1070 out of Los Angeles. 2 questions, if you would. From the time you begin the insertion, when will your telemetry tell you that indeed you're successful on coming on in and that you're getting data flow back? That's first rule. Second, radiation, wonderful. Things are coming into the speed of light. That's fine. Let's talk about human dimensions and human dynamics regarding radiation and what that spacecraft is going to survive. LD 100 for a human being is 600 rads over a space of 2 seconds. Give us an equivalent of what Juno is going to be taking a hit. Can you? I'm an old Cold Warrior, guys, so, you know, if those measurements are not up to you, I can clarify, okay?
Sure. JOI will expose Juno to about 1 million dental x-rays, or 260 some rads.
So about what, basically LD 25, lethal dose 25 for a human being, but you expect the titanium will be able to stop that and hold it out?
It's certainly better.
Question, gentlemen.
Hello, Chris Lintott from BBC Sky at Night. Can you say something about what we know about the ring particles that you were worried about? Do we know their sizes? It sounds like we don't know the density.
We know some of those, I don't know off the top of my head those answers, but scientists know the densities and rough particle distributions in certain regions of the ring plane, which we're avoiding. What's not well known is how that population evolved to the parts that are more difficult to see because they're more tenuous and that we have been unable to image. Those are model dependent. However, even the more tenuous things where the particles are not very, as dense, give you a probability that you could hit something. And so we've modeled all that to lower we believe the probability is incredibly low that we're going to hit one, but it's not zero. It's the same thing if I go through the asteroid belt. When I was younger, and I'd give talks to children, they often ask, how do you get through the asteroid belt? And the probability is very low that something's going to hit you, but it's not zero.
Thanks. And what sort of size particle are we talking about? Sort of 10 micron sort of thing?
There's a distribution that isn't well understood, but even a 10 micron particle could do some damage moving at the speed that we're moving.
I understand we have a question from the phone. Please state your name and media affiliation.
Hey, DC, Bill Horowitz, CBS News. Are you hearing me?
We got you, Bill.
Oh, okay. Thank you. I'm sorry. Yeah, just a quick follow-up on that last answer. Where does the dust and debris threat, where does that fit into your danger matrix, I'll call it, compared to radiation, or do you even know? I mean, you pretty much already scared me to death about radiation. I'm trying to decide how nervous I should be about dust.
Well, first, I'm glad you shared that radiation scare with me. But to answer your question, the radiation starts at much higher latitudes. So earlier in the orbit insertion maneuver, we will go through places where the radiation is already becoming very significant. The danger for the rings is closer to the closest approach, sort of the middle of the burn region is where the ring particles are probably densest.
Thank you very much.
Okay, great. I understand we have another question from the phone. Please state your name and media affiliation.
Hi there, it's Irene Klotz with Reuters. Can you hear me?
Yes, we can, Irene.
Thanks. Also, so Scott, considering radiation and dust and just the dynamics of the orbit insertion burn, is there an overall probability of success tonight?
I don't think I have a number that I can give you for that, but generally the whole mission is designed to have very, very high probability of success. This one little piece is probably the highest risk, but I don't have a number I can throw out that says, we're this many % of probability of success.
Thanks. And I also had a question for Jim Green, if you don't mind, not to take away from Juno, but I was wondering if you might be able to just comment a little bit about the decision on the Dawn extension to leave it around Ceres versus going to a third asteroid. Thanks.
Sure. As many know, we've announced after an extensive peer review proposals that came in for 9 missions in planetary science that have completed their prime mission. The top recommendation is all these missions are returning fabulous data, and they need to continue to do so. In the case for Dawn, an option was presented to us to go to a separate location, another asteroid. And it comes at a time where Dawn would have to leave Ceres within the next couple weeks. The senior review took that into consideration, plus where Dawn was in completing the Ceres science and projecting forward with additional science that it could do while it remained at Ceres. And it was judged by the peer review science team that remaining at Ceres provided us the best science versus going to Adiona, which was an additional asteroid. So we accepted that recommendation and told all the teams that they have been extended. And that includes New Horizons flying out into the Kuiper Belt and flying by another Kuiper Belt object.
Thank you, Jim. Go ahead, Irene. You have a follow-up?
Yeah, I just said thank you.
All right, we're going to come back to JPL and see what's going on in the Von Karman Auditorium. Emily, I understand you have a question.
Emily Lochtweiler, the Planetary Society. I have two questions. One's quick. Which of the DSN antennae is going to be the one that's primed for receiving the signals this evening?
Goldstone, we have 5 antennas at that complex, backed up and full overlap with 4 antennas at Canberra.
Thank you. And then I know you had to turn off the science instruments almost 5 days ago now, but can you tell me, you already are exploring uncharted territory at Jupiter, flying at the latitude that you are. Is everything matching your models so far?
As far as the radiation, you mean? We are not close enough to have anything that would be significant. What we did see is, as we mentioned earlier at a previous press conference, we released that we went through the bow shock and we entered into the magnetosphere. That happened much later than anybody had predicted, and so the general consensus is that the magnetosphere, at least the time that we went through that, was compressed, meaning it was being banged on by the solar wind more, so it shrunk up correspondingly. However, it's still within model constraints. That does not say a lot about the unknown territory. And in fact, there's no observation we could make this far away that would tell us something about the close-up zones, or we would have already made that with Galileo and Voyager, and we'd know what we were going in for.
Great. Okay, we're going to come back to the room here. Lady in the orange, back row.
Hello, it's Rebecca Morell from BBC News here. Can I just check, when do you declare success? Is it when you get the tones back at the end of the engine burn? Or is it when you get the telemetry information back saying that Juno's where you want it to be? And when do you get that latter bit of information back about the telemetry information?
Well, from a technical perspective, we'll be in orbit when the main engine burn is completed 20 minutes. But we want the whole enchilada because we want to be in the right orbit, not a 1,000-day orbit. So a lot of us will be waiting until the end of the 35-minute burn when we will get a tone. And as I said, that tone will be music to our ears because that'll mean we're exactly where we'd planned to be.
And when do you get the telemetry data back as well? Does that come a bit later?
Well, all the times we've talked about here are Earth received times. So the main engine burn on the spacecraft completes at 7:30 Earth time, but we don't get the telemetry, it starts, and we don't get the telemetry telling us the burn started until 48 minutes later. So when we talk about 8:18 to 8:53 p.m., that's Earth received time.
Okay, great. Thank you very much.
Let me just add that everybody has a little bit different feeling when they relax. And I won't exhale until we're sun pointed again.
Okay.
So the engine burn is a huge thing, don't get me wrong, but until we're back on sun point, because we're solar powered, that's when I finally start to say, okay.
Well, and what time, how long after, what time is that approximately? When do you get to rest?
It's around 9:30.
9:30.
By the time we'll spin down to 2 RPM and be turned back to sun.
Great. Thank you.
Okay, thank you, Rick. Any more questions from the gentleman in the back row there?
Hi, good morning. Andrew Mullenbeck from KFI. How quickly do you begin learning information about Jupiter, and what sorts of information will you learn first?
So the first orbit is 53 days long. So the next time we come close to Jupiter, which is where we really delve in and start to look for, have all the eyes and ears of Juno on, will be at the end of August. And even though that's really something to just sample and see how the instruments are going and check the environment very close before we go down to the 14-day orbits, we'll learn a huge amount from that first pass. But I'd also like to emphasize that on approach, as Emily already pointed out, we're getting data, we're looking at stuff. We shut off the instruments a couple of days ago, but we'd already started to look at Jupiter and its interaction with the solar wind and the aurora, And so the scientists are already combing through that data, learning about things. So we're already producing things that are scientifically important. But the real investigation of getting in close happens at the end of August.
Thank you, Scott. And I understand we have a question from the phone. I believe it's Keith Cowling of NASA Watch. Keith?
Hi, a question for you folks, for Dr. Bolton or anybody on the mission team. The last time you had a spacecraft in orbit around Jupiter, there really wasn't anything approved that would come back to be in orbit. Now, depending on who you listen to, you either have 1 or 2 missions to Europa. And so the question being, given that these orbital missions aren't that common or frequent, do you have a special section of the bleachers set aside for the Europa guys, like the cheap seats, to sort of look over your shoulder, given that although the radiation is an issue, the orbits may be different, nonetheless it does represent a unique opportunity to look at a very difficult mission.
So let me take that. What Keith is referring to is we have in the planning stage, and it's a very early planning stage, a formulation of a Europa mission. And because Europa is sitting in the radiation belts, it was well explained, and it's in a really tough environment, we had a couple decisions to make whether we could actually put something in orbit around Europa and allow it to last, and we find out it doesn't last very long. So we had to be more creative. And so concepts like Juno, where we can orbit the planet with specific flybys of Europa on multiple occasions over and over again, allows us to put together a complete picture of what Europa is like. This is exactly what Cassini is doing at Saturn by looking at multiple flybys of Titan. We have about 75 or 85% of the surface knowledge of Titan from those flybys. The Europa mission, though, is not about Jupiter. That will be done by Juno. It's really all about Europa itself. So it's going to look at its composition. It's going to look at high-resolution imaging. It's going to look at the surface, how it changes over time, tidal forces. Ground-penetrating radar will tell us perhaps how deep the ice shell is at various locations, because we know underneath the ice shell is a huge ocean with perhaps twice the amount of water that we have here on Earth. So Jupiter's environment, where the tidal forces are so great, that's changing the structure of these satellites, these Galilean satellites, allow us to go back to Jupiter in another mission. So that's just at the drawing boards. We're not planning to put any instruments on this Europa mission that would delve into looking at Jupiter. It's all about Europa.
Thank you, Jim. We're going to go back to the phones again for, I understand, Leo Enright of Irish TV. How are you doing today, Leo?
Hi, DC. Good to hear you. This is a question for Rick, but I'm a bit reluctant to ask it, so maybe Jim and the scientists might want to kind of close their ears and hum. But I'm wondering if, in a situation where the engine burn for some reason doesn't work, has there been any contingency planning, or is there even any point in having contingency planning to try and do some data collection on what would, unfortunately in those circumstances, unlikely, would be a flyby mission?
Well, I'll give the first answer, and Scott can add to it, but our instruments are off right now, so normally if you do a flyby, you have your instruments on. Right now, we don't plan to turn them on in a nominal sense until 50 hours afterwards. And we pick up such an incredible velocity boost from Jupiter that if the main engine doesn't fire, we're just slung out the bottom of the planet like a like a bullet. And so we'd have to move pretty quick to turn the instruments on faster. We'd want to do that in a safe way, of course. And we would take a quick look at whether there was some maneuver we could do to alter our trajectory and allow us more time to look at Jupiter. But we move by so fast, I think we lose most of the opportunity.
And if I might, DC, could I ask a follow-up of Scott? Again, a slightly speculative scenario, but are there any circumstances in the orbital geometry that would allow you to do some direct sensing of the Jovan moons, you know, the magnetosphere of Europa, the magnetic field around Europa, stuff like that, or is that not a possibility?
We generally don't go close enough to look at, you know, in situ samples of that type of territory. We try to avoid getting very close to Europa. However, we have, you know, remote sensing instruments on board. We have a very unique perspective because we're in polar orbit, and we will have opportunities to look from afar at the Galilean satellites, and we certainly plan to do that. And there will be some science value to those kinds of observations, and we may learn some things that are important about Europa, and we have some people on the team, you know, that share where they're part of the Europa teams and they're on the Juno teams, just like we also have people that are on the Cassini team. And as an example, I'm on all 3 missions as a scientist, so we certainly will do what we can, but we won't go directly in and look at the magnetic field of Europa.
Okay, thank you, Leo, and thank you, Scott. We're going to go to social media in a moment here, but I understand there's a question from Mount Carmel Auditorium. Please state your name and media affiliation.
Amanda Barnett with CNN Digital. About the camera, that great image you had earlier, when will we see more photos? When will Juno Cam come on, and what can folks expect to see? And a second question, how soon will we know whether there's a core at Jupiter? Tell us a little bit about the science behind determining the core.
Okay, so first question was about the camera. I believe it's planned to go back on a couple days after JOI, and we'll start taking pictures again. I don't think we have a plan exactly of the release. It depends on what we see and how interesting it is, but we'll certainly release periodic images, and as we approach the planet again, very close at the end of August, I expect to have quite a few images, and we will release those, including some of our first glimpses of the polar regions, which will be very exciting. What was the second question? I forgot, I'm sorry.
About the core.
Oh, the core,
how do you
right.
detect the core? Tell a little bit about the science behind that and how soon you might know something.
Okay, so the core works, the core science of trying to constrain whether Jupiter has a core of heavy elements is what that question is about, which is a very important question. It works a little bit similar to how Rick described knowing that we're in orbit. We're looking at the path of the spacecraft as it gets very, very close to Jupiter, and we're looking at how that path gets distorted by the pull and tug of Jupiter's gravity field. And one way to think of how we sensed whether there's a core or not is Jupiter is not a perfect sphere. It's what scientists call oblate, which means it's fatter in the middle than it is at the top. It's squashed. And as we fly by very, very close, we look at the signal from the radio and can tell how it's being changed, which gives us information about how squashed exactly is Jupiter. We have a very good measurement of how it's squashed, but to really sense what's going on inside, we need to add a lot of decimal points to that knowledge. And that's exactly what Juno does, is we go by and we add a whole bunch of extra points of accuracy, so to speak, to exactly how squashed is Jupiter. And it's spinning, which is why it's squashed, then that tells us about how the interior must be structured. And so it's a bit more complicated than the way I'm describing, but that's sort of how it works. And we will get our first indication of that at the end of August when we fly by really close and the radio system is on completely with all of its bells and whistles. But even then, you need multiple flybys to do this. So I'm hesitant to promise when we will know the answer about that core. We would like all the orbits, and that may keep modifying the scientists' understanding, but certainly I think until we get into our 14-day orbits, we probably won't be able to say very much about the details. We will be learning and constraining it, but we'll be hesitant to guessing the wrong answer until we see some more information.
So Juno is very susceptible to mass variations. And of course, there's convection zones right below the cloud tops that we see, and that changes the mass distribution, and that has to be taken into account too.
As well as each flyby has the satellites in a different arrangement, as you would imagine. They're orbiting around. So they're pulling and tugging on Jupiter as well, called tidal forces, the same way our moon works on us, which is why the ocean's fun to go in. So it's doing that to Jupiter's atmosphere as well. So each time we fly by, we also have to calculate where were the satellites and try to understand those. And you can learn about the interior of Jupiter by doing that as well. So each flyby, or I should say each orbit that we have, has a different longitude that we're passing, as well as a different arrangement of the satellites, and all of that goes into our database in order to interpret.
Thank you, Scott. Understand we have at least one more question from Von Karman, but first we're off to the World Wide Web. Jason, do you have some social media questions?
Indeed, there's lots of interest out here. So first question comes from Twitter user Aaron, who asks, is it possible that Juno could discover new moons of Jupiter, or is the mission only focused on the planet itself?
No, I think there's no question we will probably discover new moons of Jupiter. We have quite a few cameras on board. Some are just star trackers, some of them are more powerful like Juno Cam, but they're very sensitive to being able to find moons of different sizes in different places. Obviously, I can't tell you where to look to find those, but I expect that we will see some, and the number will keep going up.
Serendipitous discoveries.
Right.
Yeah.
Wonderful. Twitter user Michelle asks, what is the most exciting possible new discovery or piece of information that you hope to gain from Juno?
So it's hard to say what the best new discovery will be, because I can't imagine what the discovery is. Almost any of it is exciting to me. One of the most important scientific measurements for me personally is understanding the core and the water abundance, because I'm really curious about what the beginning was like in the solar system.
So for me, in addition to the core, the magnetic field structure, Jupiter has a very complicated structure, although as we showed, those field lines look very much like the Earth. We call those dipole. As we get closer to the planet, we'll find additional currents are creating new types of fields. There might be several current systems inside of Jupiter. And so understanding those contributes to the entire magnetosphere, connects with the aurora, and really tells us a lot about that whole system. So I'm quite excited about that.
And actually connects to the interior structure as well.
Correct.
That measurement is incredibly valuable to almost every objective we have.
Wonderful. Twitter user George here asks, when Juno will be deorbiting, is there any chance that Juno Cam will be able to return final images from under the clouds?
Ooh. A picture from under the clouds? Boy, I would love that. So physically, there's no reason to say that that can't happen, because the spacecraft, if it's operating, the instruments would work as well. However, as we go into the atmosphere of Jupiter at the end of the mission, the drag from these giant solar arrays and us spinning, it's a big spacecraft, right? We're going in with wings, basically, is going to start to turn our spacecraft and take control of the pointing. We'll be wobbling, as Rick is pointing out. And as soon as that happens, enough to the point where we can't maintain the signal of the antenna pointing at the Earth, we won't be able to transmit the data. So JunoCam may get a great image. The question is when's the last time it can send it back? And I can't predict that, but I sure hope we can see really close in the clouds.
Thank you, Scott. Understand we have a follow-up from Bill Harwood, and then after that, we're going to come back to Von Karman Auditorium. Bill Harwood, CBS News, do you have a follow-up question?
Yeah, I do. Thank you very much. And it's for Scott. Could he talk for just a moment, please, about the Great Red Spot and what Juno might contribute to understanding what's powering that and how deeply it extends into the atmosphere, maybe answering the whole question of just what it is and how it's working. Thanks.
Yeah, that's one of my favorite topics. I love that Great Red Spot. So we don't actually understand very much about the Great Red Spot. We see it evolving, and in fact, it's getting smaller since I first got amazed by it, which was when I was a child. So it's shrinking, but it's a giant storm, obviously. The fact that it's lasted so long, because there's records of it going back hundreds of years, most scientists think that means that it must have fairly deep roots. And that's one of the key things that Juno gets to address is we have instruments on board called the microwave radiometer, which is basically listening from deep down of what's happening with the temperature and the pressures at Jupiter. And so one of the questions is as we see down into the depths of the atmosphere, do we still see hints of the structure of the Great Red Spot? So I think how deep the roots of the Great Red Spot and how that root system compares to the roots of the zones and belts and other storms that we see is one of the most exciting things that Juno is going to return. So we will delve down and kind of try to understand really what's powering that Great Red Spot. How does it work? It looks a little bit like a hurricane on the Earth, but we know it can't be working exactly like that because hurricanes on the Earth need an ocean underneath and feed off of the liquid, and then when they go on land, they change. Well, with Jupiter, it's all, gas and compressed gas all the way down. So fundamentally, we need to learn more about how the deep atmosphere and the dynamics of the deep atmosphere work, and that's exactly what Juno's set up to do.
One of the really special things about Jupiter in my mind, and is the red spot, but Juno will look at Jupiter in a way that utilizes the fact that this planet is still hot. It's like you've taken a cake out of the oven after it was made, and it has to cool. And so the manifestations on the surface, many of which are really due to that heat leaking through and causing the structures that we see. So the excitement about the red spot may tell us about how that heat is coming through the surface and how that may be very different at this location than any of the others.
That's very true, Jim. And the other thing is as we fly over very close and over the red spot at times, we'll be also sensing the gravity, and we'll be trying to determine whether there's some sort of an enhanced signal. How much mass is tied into that Great Red Spot is one of the questions. Is there a bump? Can we detect that? What does it mean? And the heat coming out of Jupiter from different depths is the key to how the microwave really works and how it also determines the water abundance. Is the water abundance different near the Great Red Spot than other spots? We don't really know that, and Juno's poised to tell us about that as well.
Thank you, Scott. We're going to go around the room here at Von Karman one last time. We have a couple of questions. This gentleman, blue.
Paul Verkamen from CNN. As you sit here, decades in the making, high risk, you've described the debris, radiation, and more. Your emotions right now as you're so close?
It's hard to describe. I'm torn with the incredible excitement and anticipation with, oh my God, we're going in. It's really happening, and it's I know it's challenging. I mean, I know the business. NASA and JPL are in the business of taking challenges. We have to do it as a culture, as our society. If we're going to go after these hard questions, we got to do the hard problems, and we got to take chances and risks. But it's all so real right now. The risk is right in front of us. It's less, I hadn't heard DC say, we're within one Jupiter rotation. I've studied Jupiter almost my whole life. That scared me.
Just a quick follow, though.
From my perspective, I've been the director of planetary science for 10 years now. I've been involved in Curiosity's landing, flyby of New Horizons at Pluto, the launches. These are enormous milestones that occur, and each and every one of them carry their own risks. But what gives me wonderful confidence about the success of Juno is how this team has worked so hard to study those risks and create a variety of scenarios and mission architectures and structures on the spacecraft to mitigate them. We have done everything humanly possible to make this mission a success. And so it's still a cliffhanger for me too.
And yet somehow you haven't lost your sense of humor. What does it say about you all that you have 3 Lego figurines on board?
That I wasn't thinking that much risk back then.
Great, thank you very much. And we have one more question over there.
Yes, hi, Mike Wall from space.com. Sorry to keep dwelling on the risk, but like if you could quantify, what are you most afraid of tonight? Are you most afraid of radiation? Are you most afraid of the kind of dust in the ring? Are you most afraid of the engine, like whether it's going to fire on autopilot or not? Can you kind of quantify what's the biggest thing that you're scared of tonight?
I'm not sure at least for me, that I can identify one thing that I'm most scared of. The bottom line is Jupiter is extreme in every way. I mean, I studied the radiation belts a lot, and so I know more about those, and I'm maybe scared more because of that. But the truth is it has the strongest magnetic field. It's spinning the fastest. It has the strongest gravity field. It has the most intense radiation, and we're flying the fastest of any spacecraft, and we're carrying these giant solar rays spinning. So that all sounds okay, but I also look at it and I'm like, what were we thinking? But as Jim said, we've got the world's best engineers working this out. We're doing everything humanly possible. I'm confident it's going to work, but I'll be happy when it's over and we're in orbit. So to sum it up in one thing, I'm really just nervous that the whole orbit insertion rocket burn is going to work enough to get us into an orbit and then allow us to turn back to the sun before we run out of battery power. So, one thing that we didn't emphasize is that as soon as we turn off the sun, there's a time clock that starts. It's a stopwatch. And that means you're on battery power. The whole game is get back to the sun before you run out of battery. And in the middle of it, I have to do this orbit insertion burn. But I've got to get back to that. And I felt this exact tension almost at launch. So it's not brand new. At launch, I'm sitting there watching. I'm thinking, wow, 22 years since we launched something to Jupiter. Galileo was the last one. And now we're finally going back. I'm so happy I'm part of it. And then I was scared watching the rocket going, oh my God, Juno's on top of that firecracker. And I had my fingers crossed and I was excited but tense, and it went up. Everything worked great. I came down. One of the NASA managers was there next to me. He goes, how you feeling? I go, God, we did it. We launched. He goes, you're not done yet. Got to get the solar rays out. Got to point to the sun. And that was a sobering moment because I was excited about the rocket. And basically, we've got to get the blood flowing through Juno's veins again. And that's the key. So maybe I'm most scared of not getting back on the sun.
Well, thank you very much, Scott. Well, that's going to wrap it up from here today at JPL.